Welcome to this presentation on multiple in, multiple out, or MIMO. This presentation will give you a brief overview of the MIMO technology and some of the other key technologies which make MIMO possible. MIMO technology can be used to help improve wireless access in a number of different applications. Today, many of us are using MIMO in Wi-Fi applications. MIMO can be used to help improve the efficiency and reach in Wi-Fi applications such as hotspots or within the home where you're using wireless connectivity. It can also be used to provide a wireless alternative to cable and DSL for last mile broadband access using WiMAX. Again, MIMO plays an important part. MIMO can also help improve the efficiency in providing high-speed mobile data and telecommunication services for 4G and long-term evolution, or LTE. It seems rather counterintuitive, but MIMO actually relies on lots of interference. That is, we don't want a direct signal path between the base station and the subscriber station. For MIMO to have full advantage, we need good diversity in the signal propagation. So anything which interferes with the signal path, such as buildings, natural objects, aircraft, people, cars, etc., are going to actually help in the overall efficiency and effectiveness in MIMO applications. So let's take a look at exactly how this MIMO technology works. So one of the key technologies that enables MIMO, as well as LTE or long-term evolution, which is being used in the next generation of cell phone technologies, is orthogonal frequency division multiplexing, or OFDM for short, which is a lot easier to say than orthogonal frequency division multiplexing. Basically, in traditional systems where symbols are being transmitted, a symbol, for example, is a piece of information, a relatively broad bandwidth is used for each one of the symbols, and each one of these symbols is transmitted typically sequentially for a relatively short period of time. If we look at how OFDM is used, we transmit multiple symbols in parallel, each symbol using a relatively very narrow piece of spectrum or narrow bandwidth. However, each symbol is transmitted for a much greater period of time. This has a major advantage. When receiving the signals, it's much easier for the receiver to pull in each one of the symbols. Even if the signal degrades somewhat, we've got a far better chance of pulling in one of those symbols due to the fact that each symbol is transmitted for a much longer period of time. This is very important when working in MIMO type environments. This diagram actually compares a traditional single carrier with OFDM. On the left, we can see that using a single carrier transmitting a symbol, if there is interference in the signal, enough of the signal can be degraded so that it's impossible to receive that particular symbol or piece of information correctly. However, if we look at the OFDM methodology, you can see that multiple frequencies are being transmitted in parallel. This is actually enabling us to transmit multiple symbols in parallel. Also, remember, each symbol is being transmitted for a longer period of time. So even when the signal fades or takes a diverse path, we can still in many cases recover enough information from the frequency received to recover the symbol. Now, of course, in real life, the spectrum is going to vary in terms of data loss or loss of signal, and it's going to be dynamic. But generally speaking, due to the fact that the symbols are transmitted for a greater period of time, and remember the advantages they are also being transmitted in parallel, we have a far better chance of recovering that information at the receiver. If you ask most people how a radio transmitter and receiver typically operate, they'd most probably tell you, well, you have one antenna for the transmitter, one antenna for the receiver. The radio transmitter transmits on one given frequency, and the signal goes directly to the receiving antenna. And this is how most people would most probably view radio operations. However, MIMO is completely different in terms of operation and, most importantly, in terms of efficiency of spectrum. In a MIMO system, or multiple in, multiple out, we actually have two antennas which are used to transmit and two antennas which are used to receive. Now the interesting thing is that both of these antennas which are transmitting are actually transmitting on the same frequency, but different data is transmitted out of both antennas. So again, if you ask most people how is this going to possibly work, they would most probably tell you it's not, because the frequencies will interfere with each other and the data will obviously become corrupted, because you can't have two antennas operating co-locatedly on the same frequency transmitting different types of data, because obviously they're going to interfere. However, using some very advanced digital signaling processing technology, it is in fact not only possible to transmit data on two antennas using the same frequency simultaneously, and on the receiving side, for these antennas to differentiate between the data streams, it's also a very big advantage in terms of the efficiency of the spectrum utilization. You, in effect, double the efficiency. If more antennas are used, you can triple or quadruple the efficiency of the overall system. Now, how can this possibly work? So exactly what does MIMO do and how does it operate? Well, remember, MIMO stands for multiple in, multiple out. In this case, on the left-hand side of the diagram, we can see the base station transmitting on two antennas, A and B, over to its partner station, the mobile station. It could be a fixed station, again using two antennas, A and B. Each one of the transmit antennas is operating on the same frequency, but transmitting different streams of data. On the receiving side, we're able to differentiate between the two streams and recombine the data into a single serial stream. We're able to do this due to the fact that we've got some very powerful digital signaling processors in effect unscrambling the signal. But it's only possible to unscramble the signal when the signal arrives at different intervals of time. Basically what we're looking for is good signal diversity. The signal diversity is created by the fact that the signal is not taking a direct path between the transmitter and the receiver. The signal is actually bouncing off possibly man-made objects such as buildings, planes, trains, people, cars, or off natural obstacles. This diversity in signal arrival makes it possible for the DSP technology to unscramble and recombine the data streams. Now, how do we test? Well, you could go into the field and run live tests out in the open field, but these tests can take a long time to perform and can be difficult to recreate, and also could be relatively expensive. So what Spirent has done, we've basically developed a piece of test equipment which models this environment. Using some very clever and advanced spatial channel models, we're able to recreate these conditions of signal diversity. We can also vary these conditions dynamically, giving you a very realistic environment to test both your transmitting and receiving equipment. One of the key advantages of the SR5500 is its ability to model very realistic conditions of diverse signal propagation. For example, within a city environment, conditions are going to change throughout the course of the day. So it's not very realistic to have a piece of test equipment which only runs a model for 10 seconds and then repeats and repeats and repeats. In a real city, for example, signal propagation is going to continually change. Very early in the morning, when there are very few people on the street, you're going to have one type of signal propagation. As more and more people come onto the street, more and more vehicles operate, trains, planes, automobiles, etc., signal conditions will change. So the big advantage of the SR5500 is to model the changing environment over a 24-hour window. This makes for a much more realistic test for your MIMO equipment. Thank you very much for watching this presentation. If you'd like more information on Spirent equipment and products, please visit our website at www.spirent.com. And while you're there, don't forget to check the website to see if there's going to be a live seminar near you coming soon. For a copy of this presentation, you can visit my wiki at allentestwiki.pbwiki.com. You can download other presentations from the wiki as well, plus some other useful tools. If you'd like to look at other videos on YouTube, please search on Alan Talks Tech. Once again, thank you for viewing this presentation.